Hi, Mr. Pepperell here, and in this video I'm going to be talking to you a little bit about electric current, what it is and how we calculate it.
So, electrical current is a flow of charge. When you flip the switch on an electrical device, what happens is negatively charged electrons that we can see here start to move through the wire, through the circuit, and they transfer energy to components such as this bulb when they get to them. So the size of the current flowing is actually the rate of flow of electric charge. Well, what does that mean? Well, it's the amount of charge which flows every second. Okay, so the more electrons that flow through a component like a bulb in a second, the bigger the current is. Can we measure the current and the charge in an electric circuit? Yeah. Well, we can measure the charge, firstly, in a unit called the coulomb, okay? Just like meters are a unit of distance, the coulomb is the unit of charge, and you give a small m for meters, you give a capital C for charge, okay? And in an equation, it's represented, confusingly enough, by a capital Q. Okay, now the rate of flow of this charge, or the current, is actually measured in something called amperes. So current is measured in amperes, or more commonly it's just referred to as amps for short. Okay, and you'll see it with the capital A next to the number for how many amps there are, and in an equation, again confusingly, it's given by a capital I. The only reason they use these strange, you think, well, why are they using a capital Q and a capital I? You know, C had already been used for something else, so they had to use a different letter, so they used I. Okay? So what does this actually mean? Well, what we can say is that a current of 1 amp is actually a flow of 1 coulomb of charge per second. So every second that goes by, 1 coulomb of charge is flowed through a component, and that is a current of 1 amp. Okay, so from that we can sort of see that current and charge are related by an equation, and that equation is this one. Okay, current measured in amps is equal to the charge measured in coulombs divided by the time measured in seconds. Okay, and to make that equation even simpler, we can just show it like that. Okay, so I for current is equal to Q for charge divided by T for time. So let's apply that equation to a real life situation. Here I've got a charge of 8.0 coulombs passes through a bulb in 4 seconds. What is the current through the bulb? Well, all I have to do is use my equation that current equals charge divided by time. So if I put my figures into that, I've got here current equals charge, which was 8 coulombs, divided by the time, which was 4 seconds. So my current was actually 2 amps.
So that is what you need to know about electrical current. Any problems with that at all, don't hesitate to tweet me at Mr_Pepperell on Twitter, and I'll get back to you ASAP. Thanks for stopping by.